and welcome to day 12 of the 12 Days of LiDAR. My name is Alex Billick, and today we're going to cover a recap of the last 11 days and where do we go from here. So, brief recap. We've added a few tools to your toolbox, hopefully. We've covered what LiDAR is, some of the common lingo, what those common derivatives are, some ways to view the data, some tools used to extract additional information, and we've discussed some considerations for how the data is used, especially in the context of forestry. We've talked about it mostly from an aerial perspective. We haven't gone and we talked about terrestrial lidar. We haven't talked about drone-based lidar too much. Um, I debated whether to talk about drone-based lidar or satellite-based or other applications here. But what I wanted to do is focus on some of the spaceborne because drone-based is a very fast-moving space, and b the inference space is going to be quite small. Let's talk about how we deal with very large tracts of land or national questions where the faster updates that spaceborne can provide might be very appealing. So, spaceborne lidar, is this a new concept? We're not talking about some sort of Doctor Evil scenario here, um, but we're talking about being able to measure things using the same technology. This is not new though. Again, we the first mission that we know of that isn't classified, at least, was done by NASA in September of 1994, and it was called the LIGHT mission, or LiDAR in Space Technology Experiment. It was flown on Discovery, and it had three goals. One was to validate LiDAR for space, two was to explore applications of LiDAR, and three was to gain operational experience. Since then, NASA has gone on to use LiDAR both for mapping the Earth but also Mars. So there's a lot of different applications of this technology in space. But let's talk about some data sets that you might have access to or could leverage. The first is ICESat 2. This was launched in September of 2018, and it's an example of being able to leverage the single photon concept. So splitting a green band lidar up and capturing multiple returns. The diagram in the bottom right hand corner there shows you the typical layout of these returns. So this is not going to give you the same coverage that aerial lidar is going to give you. But what's cool with this is that we get repeat measurements. So this is on its own satellite platform. It's targeting the poles, but it does cover other regions as well, and it can give us some insights there. And really, what the power of this is repeat measurements of the same piece of geography, so that we can actually look at change over time. And that idea of temporal resolution can be very helpful. The problem with this is the revisit time is quite low. It's not intended to be a mapper of forest vegetation. That's not its intent. So we can use it for that when it happens to be collecting data there, but that's not its purpose. The JEDI, or let me remember here now, the Global Ecosystem Dynamics Investigation, is a lidar that's intended to collect forest vegetation. So we get data spread out in these along tracks, different levels of power that come back, but we do get full waveform lidar with this. This is an example of what the JEDI forest canopy height model looks like in the area of coverage. We don't get the poles here. It's not intended to cover that, and so its coverage north and south of the area shown here is basically non-existent. But the ability to map most of the forested area uh, on the world and be able to give us change detection over time is really powerful. The problem is still it's not really designed for that annual cadence, that annual update. It's a snapshot in time. So it's a useful tool, but it has maybe some potential limitations to it. And this is where a new incumbent into the space is interesting. They're called NewView. They're taking the model more similar to what Planet has done with with covered, trying to increase that temporal resolution. So they're aiming for fairly high resolution lidar, but what they're really aiming for is annual global coverage. And if you can actually achieve that, that becomes very powerful because now we can, maybe the cost of acquiring annualized updates to our forest environments is cheaper than aerial campaigns. And if that's the case, and if the data quality is such that we can use it for that type of analysis, it becomes very interesting from a carbon accounting perspective, from a forest management perspective, to understand forest dynamics at a national or at a global scale. The information on them is a little bit sparse right now. They're fairly new out there, but if you are interested in learning more about New View, then check out the Digital Forester podcast. There was a great episode there where you get a little bit more background and insight into their mission and what they're aiming to do. But with that, I just want to leave you with my thanks for having made it to episode 12 and listening to this. What I ask now is that maybe you let me know in the comments what your favorite episode was, or ideas for another series. If you have any that you're really burning questions in this geospatial world, and you'd like another series. I don't know if there'll be 12, but we can explore that down the road. So thank you very much for listening.